everybody. In this video, we're going to be learning about permutations, which is basically like a special word for counting things that depend on each other. So take 3 deep breaths and let's make this math easy. All right, so in our last video, we talked about how we can use choice trees to list out sample spaces. And in all of the examples we did in that assignment, each event was independent from the next event. So for example, when we were flipping the coins, when you flip a coin and then you flip a coin again, the result of the first flip doesn't affect the result that you get when you flip the coin the second time. But that's not always the case depending on what situation you're given. Like for example, let's say that you were asked to choose a president and a vice president from a group of 5 people. So let's just label these people A, B, C, D, and E to make this really easy. Well, if I wanted to choose a president and a vice president from the group of 5 people, my first choice would be to choose a president. So I could say, okay, well, I could choose person A as my president, or I could choose person B, or person C, or person D, or person E. Any of those options would work to choose the president from this group of people. And then I would choose my vice president. So I'd say, okay, well, if I chose person A as the president, then I can't also choose them as the vice president. So when I list off my choices for the vice president, I'm going to say, well, it could be B or C or D or E, but it couldn't be A because I can't have person A be the president and the vice president. So the number of branches is smaller branching off from that because I've restricted some of my options. And the same thing would happen when I list out the vice president options for having person B be the president, because I could have person A be the president, or person C or D or E, but I couldn't have person B be the vice president because the person B was already the president. And so essentially each one of these is going to have 4 branches coming off of it, because it's restricting the fact that you can't have the same person be the president and the vice president at the same time. And so each of these will have 4 little branches coming off. And my choice tree is already getting really, really tight. So it's a good thing I don't have any more choices after this. But when you look at this, you'll notice that the mathematical calculation for finding the number of ways that you could choose a president and a vice president is going to be 5 times 4, because you had 5 choices for who you could choose as the president and 4 choices for who you could choose as the vice president. And so the number of ways that you could choose a president and a vice president from a group of 5 people is 5 times 4, which would be 20 possible ways. And that's basically what permutations are doing. Okay, so let's do another example of this. So a personal identification number, or a PIN, is basically like a security code, that you can use with your debit card or whatever the PIN number is for. And if we wanted to look at how many 5-digit PINs are possible if the PIN cannot have repeated digits, we could think about this with a choice tree. Now, we may not want to write the whole choice tree out because it would be pretty big, but we can use the idea of a choice tree to help us think about it. So the first thing I want to do is I want to think about how many possible digits are there to put in my PIN. So I know that I have the digits 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I also have the digit 0. So I have a total of 10 possible digits that I can put in my PIN. And so the first part of my choice tree will basically have like 10 branches, and I'm not going to write it all out, but I will have 10 possible options for my first number of my 5-digit PIN. Then let's say that I choose a 0 as my first digit. Well, they told me that I cannot have repeated digits, and so the number of things branching off from 0 is going to be 9, because I can use any of these digits, but I can't use the digit 0. Same thing like if I came down here to if I chose digit 5 as my first number, well, the branches coming off of 5 will also have 9 options, because I could do 1, 2, 3, or 4, but I can't do 5, again, because I can't have repeated digits. Then I could do 6, 7, 8, 9, or 0. So basically, on each of my 10 branches, I'm going to have 9 branches branching off of it. Then, from each of those branches, I'm going to have 8 branches branching off. Because let's say I chose a 0 and then maybe I chose a 3. Well, the number of options of where I could go from here if I don't want to have repeated digits is the 8 digits that are not a 0 and not a 3. And I'm going to keep on doing this until I have 5 digits altogether. So this is the number of options for my first digit. This is the number of options for my second one and my third one. And then my fourth one would have 7 options, and my fifth one would have 6 options. And so the number of possible pins that I could have if the pin cannot have repeated digits is 10 times 9 times 8 times 7 times 6, which equals 30,240 possible pins. So if you were ever trying to guess someone's pin, that would be a lot of guesses that you would have to go through to be able to figure out what their pin number is if you were purely just guessing. So this is another example of a permutation, because it's kind of this idea that as you make more choices, your choices become more and more limited. So like in this case, you couldn't have repeated digits. In the last example, if you chose the president could not be the vice president as well. All right, so to practice this, I want you to try this one on your own and figure out how many 8-character passwords are possible. And we're going to put the restriction that you can't have any repeated letters or numbers or symbols in your password. And let's also say that you can only use the uppercase alphabet and the numbers 0 through 9. So you can't use the lowercase letters, and you also can't use symbols like @ or $sign or things like that. But let's just keep it simple and figure out how many 8-character passwords are possible if you have uppercase letters, the numbers 0 through 9, and you can't repeat any of the previous symbols that you've used. So pause this video, try this example, and then restart it to see how I would solve it. Okay, so the way that we would solve this one is, first of all, we need to figure out how many options we have for the first character of our password. So at this point, we can use any of the characters because it's our first one and we won't be repeating any of them. So we'll say, okay, well, there's 26 uppercase letters and there's 10 numbers. So that means the number of possibilities that I have for the first character of my password is 36, because I could choose any of my 26 letters or any of my 10 symbols. So if I was drawing a choice tree, the first layer of my choice tree would have like 36 different branches, and I would have all of the uppercase letters and all of the numbers labeling those branches. Then, once I choose my first character, then I only have 35 options for what my second character can be, because I can't repeat what the first character was. So I would multiply by 35, because each of these 36 branches is going to have 35 branches branching off of it. And then each of those 35 branches are going to have 34 branches branching off of them, because the third character cannot repeat the first or the second one, but you'll still have 34 options after that. And then you'll have 33 options for the fourth character, 32 options for the fifth one, 31 for the sixth, 30 for the seventh, and 29 for the 8th character. Notice that the number of numbers that I'm multiplying by, or the number of options that I'm multiplying together, matches the number of choices I'm making, because I'm choosing 8 different characters to make my password. And I could calculate out what this number is. So if I do 36 times 35 times 34 times 33 times 32 times 31 times 30 times 29, I end up getting this very, very large number, which is 1,220,096,908,800. So that's the number you get when you multiply all of these together. And as you can tell from how big that number is, it's a really good thing that we didn't try to draw the choice tree out, because essentially you would end up with trillions of branches at the end of your choice tree. So as we continue with these lessons, you're going to find that the choice tree method is more of a way to think about it. You aren't actually going to write out the choice trees very often, because in most cases, the choice trees will be ginormous with tons and tons and tons of possibilities. And so what we look at is how many possibilities there are. We don't necessarily list out the entire sample space, because that would be a huge, huge list. So that's how you calculate permutations. If you have any questions, let me know. And I hope you guys have a good day.